This is the first part of Chapter 2, exploring data with graphics and numerical summaries. First, we want to understand the difference between variable and observations. A variable is any characteristic observed in a study. Observations are data values observed for a variable. Observations can be numbers or a category. Here is an example. The following table was pulled from information at the following website and contains information about the 2016 U of FC football season. Part 1. Identify two variables and two observations in the above dataset. You can pause this video and try to identify two observations and two variables by yourself. When we try to identify variables, we should look at column headers. For examples, game ID, month game was played, and etc. are called variables. All those column headers are variables. When we try to identify observations, we should look for the cell under the columns. For example, September in the second columns, tendencies in the third columns, 3.20 in the column of length of time are all observations. There are two different types of variables. The first one is called categorical variable. Categorical variables are those where each observation belongs to one of a set of distinct categories. The examples are yes and no response and gender. The second type will be quantitative variable. Quantitative variables are those observations that take on numerical values that represent different magnitudes of the variable. For example, measurements or counts are quantitative variables. More examples are age, income, number of siblings. Note that not all number responses are quantitative. For example, your phone number and the zip code are categorical variables. They are not quantitative variables. Quantitative variables can be placed into two different subgroups. The first subgroup is discrete quantitative variable. Discrete quantitative variables are those variables where the possible values form a set of separate numbers. The key phrase will be the number of. The outcomes are counts, for example, 0, 1, 2, 3. Discrete quantitative variable has finite number of possible values. There should be no decimal in discrete quantitative variables. The second subgroup will be continuous quantitative variable. Continuous quantitative variables are those variables where the possible values form an interval. The outcomes of continuous quantitative variables are measurements. Continuous quantitative variables have infinite number of possible values. Decimals are allowed but are not required for continuous quantitative variables. Here is workflow you should follow to determine if a variable is categorical or quantitative. First, are the values of the variable numbers? If the answer is no, then the variable is a categorical variable. If the answer is yes, then we should try to answer the next question. Would the average of all the values be meaningful? Or is the variable a measurement or a count? If the answer is no, then it is a categorical variable. If the answer is yes, then it is a quantitative variable. Phone numbers are numbers. But if you were to take everyone's phone number in the classroom and calculate the average, the value won't be meaningful. So phone numbers are categorical variable. Next, we will learn how to determine if a quantitative variable is continuous or discrete. Option 1. Could the value contain a decimal? If the answer is yes, then it is a continuous quantitative variable. If the answer is no, then it is a discrete quantitative variable. Option 2. Are you counting the number of something, or is the value a measurement? If you are counting the number of something, then it is a discrete quantitative variable. If you are measuring something, then it is a continuous quantitative variable. Example 2. Identify the variable type. Identify each of the following variables as categorical or quantitative. If it is a quantitative variable, then state it is a discrete or continuous quantitative variable. First, number of pets in family. You can pause this video and try by yourself. The number of pets in family is discrete quantitative variable. Country of residency. It is a categorical variable. Choice of auto to buy, either domestic or import. So it is a categorical variable. Distance in kilometers of a commute walk. It is a measurement, so it should be continuous quantitative variable. Social Security number. It is a categorical variable, even though Social Security number contain numbers. However, if you take the average of a Social Security numbers, it doesn't mean anything, so it should be a categorical variable. Number of people you have dated in the past months. It should be discrete quantitative variable. After all, you cannot date 2.5 people. Last, the weight of a dog. It is a measurement. so it should be a continuous quantitative variable. Example 3. Identify whether the variables in the below table are categorical or quantitative. If they are quantitative, then specify if it is a discrete or continuous. First, game ID. It should be categorical. Month the game was played. It also should be categorical. Conference versus out of the conference game. It should be categorical. Number of points U of SC scored. It should be discrete quantitative variable. Length of time. It is a measurement, so it should be continuous quantitative variable. Number of pounds by U of SC. It should be quantitative variable and discrete. Next, we are going to learn the distribution of variables. The distributions of categorical variables show all possible categories and the number of observations falling into each category. What to look for with categorical variables? First, how often each category was observed. Second, finding the model category, that is, the category with the largest frequency. And what should we look for with quantitative variables? First, shape. Do observations cluster in certain interval, or are they spread thin in other areas? Second, center. Where does a typical observation fall? Last, variability. How tightly are the observations clustering around the center?